Thank you for joining. My name is Andira Schroeder. I'm the head of marketing for Link3D, and we're excited to have you here today. Before we jump into the event, I just wanted to review some of the technical best practices for the Remote platform that we're using today. So Remote tends to work best on a computer rather than a smartphone or a tablet, and Google Chrome tends to be the best browser for connection as well. If you are having connection issues, first try refreshing the page, but we've also found that sometimes a VPN may block access as well. So you may have to either disable that or try using a personal computer. I am also happy to help anyone get connected if you are having trouble. So you can message me in the chat function of Remo and we can get you connected. So now that that is covered, today we have a little bit of a different structure of event than we typically host. So Link3D's Mark Seaton and Janet Carr will be kicking it off with a 20-minute presentation on Link3D's perspective on digital transformation for AM in aerospace. But then we are honored to have two industry experts, Godfrey from SLM and Dr. William Herbert from Carpenter Additive, join us for a panel to get a broader view into what should be considered when thinking about digital transformation within the aerospace industry. So I'd like to welcome Mark Seaton and Janet Carr. Hi, Janet.
Hi, thank you so much for having us. I guess we're just waiting for Mark to hop on. Okay.
Should be able to join now.
Hi, Janet.
Hi, Mark. Thanks for joining us.
I'm really excited that everybody could join us here today. If you were with us for our events this spring, we did a digital conference, one of the first in the industry, followed up by a marathon conference. Janet, you were up for 26.2 hours, I believe.
That's right.
It was incredible. And now we're doing ongoing events in Japan and next Singapore. We thought those were very valuable for the industry, but this is slightly a tweak. We're diving into a specific topic, which is digital transformation for a specific industry with aerospace. So I hope everyone here gets a lot of value out of this. Our mission in Link3D is to help people scale additive. We're a software company that helps with additive workflow. We consider ourselves an operating system for additive, but really our mission is bring people together and let's grow this industry. And that's the purpose of this event. So as we dive in today, please post any questions in the Q&A tab over by chat. And then Janet, Will, and Don will address those questions and offer their point of view at the end. And I'm really excited that Janet's here. She's the driving force behind that. She's our head of industry for aerospace. You want to kick us off, Janet?
Sounds good. Well, thanks everyone for joining us. Really appreciate it. We have basically worked with a lot of aerospace players in the market over the last couple of years, and we have quite a few learnings from our experiences, and we'd love to share that with you today. Let's just first acknowledge who are the different players in the market enabling the aerospace manufacturing supply chain. On the blue side, you've got military and defense, the Air Force, the Navy, the Marines that are helping, that are using additive manufacturing to support their operations. You've also got commercial, aircraft, aviation, drones, helicopters, and space, building satellites to building spaceships, bringing them up and launching them into space. And in between all this, we've got OEMs that are supporting many different industries in this sector, but also on the white side, a huge supply chain of folks supporting, maintenance, repair, overhauls, MROs, producing spare parts on demand, tier 1, 2 contract manufacturers that help support the production of end-use parts, especially when OEMs decide to make or buy, and they're going towards the buy side, and also service bureaus, filling in the gaps, helping launch more awareness into additive manufacturing and finding more use cases to help these OEMs build up their competency and help them scale up. And all these organizations help in many different use cases from, prototyping, developing tools, jigs, and fixtures, spare parts to developing R&D initiatives to identify that recipe for enabling quality production of end-use parts. But there are a lot of challenges that we still as an industry must overcome. And I'd like to pass this over to Mark.
Yeah, it's a complex ecosystem, additive and aerospace. And the challenges aren't concentrated in one of the players or another. You think about distributed manufacturing. When we were all experiencing COVID, people first thought about supply chain issues. But really, we think about distributed manufacturing as disaster recovery. If a facility goes down, how can you instantaneously reroute orders and keep all the underlying data, not lose anything? Also with part qualification, simply getting a flying part qualified is a Herculean task. Maintaining qualification is difficult as well, especially if you don't have the underlying unified data layer to maintain all the information. It's a huge challenge to create that data trail.
And speaking about data trail, we're talking about having the infrastructure to capture the end-to-end workflow. And if we're able to capture all the data that's relevant to enable demonstration of quality compliance, then we're definitely able to help achieve that goal of manufacturing repeatability. But we all know we're also challenged with not only the software side of capturing data, but also with making sure that our assets, our equipment on the floor, even though we all know in the industry, you buy the same make, model, serial number to serial number, there are a little bit of gaps or differences amongst the machines. How can we make sure that if we have the data infrastructure to capture the data end to end, we can then be able to identify and highlight differences, and with that, enable organizations to then dial in on these differences and match the processes so that we could still achieve the same quality output. Lastly, security. There are many aspects to this, especially for the aerospace industry, from how do you manage counterfeiting of parts? If a part is being scheduled to run for production and a malicious attack is made, how can we make sure that nothing is obstructing the layers that are being printed and the program used to run this on the machine? Internal security. How can we put in the right access and control so that we know only ITAR-specific folks that are qualified are able to produce those parts, and those that have commercial qualifications only focus on what they have to focus on. So creating that layer is important to make sure that everyone is risk-free. Along with encryption and cybersecurity, how can we make sure that the data packages, the process parameters, that recipe is secure as you are enabling distributed manufacturing across your own internal facilities halfway across the world, or also with your contract manufacturers, MROs, and service bureaus that you trust?
Yeah, Jenna, it feels to me, in summary, you've got a lot of different players. You've got these challenges that come down to process and eliminating risk. Nobody wants the auditors banging at your door. Everybody wants to show the return on investment for additive, but it also applies to each use case. You may be doing R&D, and if you look at this slide, it's going to get real busy, so let's clear it first. At the top in the blue, these are the different use cases we see: R&D, prototyping, all the way through series production and jigs and fixtures. Each of those use cases has the same considerations. Janet talked about security. How do you capture an order? Do you need to provide an actual cost estimate, or do you need cost of materials and employees and machine utilization for your CFO? How do you plan, maintain quality, and then deliver the part? You've got different use cases and different considerations within each. And Janet, let's take prototyping as an example. How would you dig into that?
I'm glad you asked. So there's actually a lot of commonalities between prototyping, R&D, series production, and tools, jigs, and fixtures regarding the considerations that Mark just listed. For prototyping, just simply on the security side, I reemphasize the need for, especially in aerospace and defense, an ITAR and EAR workflow to make sure that everyone's risk-free of processing these restricted parts. Then you have to ask yourself, how about your data infrastructure? Is it going to be on premise, or is it going to be on a private cloud? And if it's within a private cloud, is it going to be a government cloud? And which one? Everyone has its own pros and cons. It really depends on your operations and your volume of activities. And this also includes SSO and access control. How do you make sure that your employees have a sustainable model so that if they're still with your company and they, get more access and control access, how does that look like? If they're no longer with your company, how do you maintain security as well? Along with counterfeiting and distributed manufacturing, how do you send that data package securely across your supply chain? These are all important questions and considerations you must ask yourself as you are building out your a more secure and sustainable model to support your additive manufacturing operations. That said, on the RFQ side, simple things like centralizing your orders, capturing that end-to-end digital trail. On the costing side, questions you need to ask is, are you trying to capture all the costs for your long-term agreements and being able to calculate the cost of the entire program? If you're on the service side, are you looking at value-based pricing? Something that's for prototyping for one industry to another might require different levels of effort. And how do you price that in and track it? We're also talking about build prep connectivity or simulation pricing. How do you capture actual material usage, actual material wastage, and the production time to help bring the part to market? On the production and planning side, we're looking at how do you manage distributed manufacturing and disaster recovery? If you need to scale out routing and capacity management, how do you do that at a glance? And then on the digital traveler side, being able to capture all of your standards of operating procedures makes it easier for building a sustainable business, because as you're hiring more people, making sure that they follow your instructions is important to making sure everything is processed repeatedly. That said, most recently, a lot of machine manufacturers are also enabling what we call machine connectivity. So you can start monitoring your shop floor, not only on the operational side, but also on the sensor side, being able to track what are your min and max tolerance levels, being able to alert the shop floor so that they could be more proactive in making sure each part is produced to spec and each part meets your compliance requirements. That's important, along with capturing all the defects that might take place through the production and capturing that inequality system so that you can close that feedback loop. Are you closing it to demonstrate quality output, or are you also closing it to identify bottlenecks on the shop floor so that you can solve it to create a healthier profit margin within your operation? And by having all the data points connected, you can now swoop in and connect all the data points so that you can start analyzing the data, apply SPC controls so you can find trends, correlations to better improve your operations. And finally, simple things like logistics definitely help, logistics management definitely help with making the small things easier, because no one wants to re-update information about the contact, where they're going to be shipped to, and all that information into your courier system. Having that integrated really helps streamline your operations so you can focus on value-added activities.
And Janet, when you shift to series production, what changes?
Great question. So on the series production side and spare parts side, we're talking about parts that have been qualified. These parts have fixed workflows, they have data packages that are aligned. And so normally these are actually stored in your ERP system. So you can start collaborating with your procurement team as part of your overall company infrastructure, because additive is now part of the supply chain. So being able to house that data, catalog it for easy ordering on demand. On the production side, if we're able to track and monitor the machines, that means we want to make sure that all the production workflows follow your recipe. So having your fixed process built in to your operating procedures will help ensure that your colleagues could follow the steps and that we're able to demonstrate that they've complied or not. And that brings us to the last point. Quality and being able to generate that digital certificate of conformance and that digital data book to demonstrate that, yes, I have met the recipe requirements, and yes, this is a part that you can accept. Thank you very much. Let's work on the next program together.
Yeah, a lot of considerations, and folks, we had a lot in that slide. If you'd like a copy of the slides, feel free to email Janet at link3d.co. Janet's email address will be on one of the subsequent slides as well, or anybody at Link3D, and we're happy to give you the detail on this. So now we get to what decision you're going to make. You're a player in the space, whether it be R&D through series production. You've got the foundational challenges and all the things you need to consider. You can, one, look at your existing system. Maybe it's an ERP, maybe it's homegrown, and adapt that for additive. You could build something custom. We all have very smart IT teams, or you could adopt an additive specific operating system. And there's been a point of view in the industry recently, which is you need to start and get the fastest digital MVP up and running versus boiling the ocean. And what you want to get is the high strategic value for the lowest cost, essentially bang for the buck. So as we look at these, adopting an existing system, you're not going to get the most strategic value. There's some things it just can't do by shoehorning a non-additive system in. And it's going to take a lot of work and maintenance to keep up with what is a really rapidly innovating space. Building something custom, you may be able to make it perfect, but it's going to take all of your organization to keep it. And what if a leader in IT leaves? It becomes something that may not be your core competency. Whereas an additive operating system, you're going to get all that strategic value and not have to deal with the maintenance and configuration. But this is very high level. Let's drill in. And the way we've chosen to drill in on this is by creating a graph. On the y-axis, that's your strategic value, high to low. And then inverse on the x-axis, complexity all the way to relatively easy. What you want is top right corner. That's your highest bang for the buck. So if we're not gonna consider an existing system, you're just not gonna get the best outcome with that. But if you were to adopt build a custom solution, what's a good example to look at? Machine connectivity, Janet? Or where would you drill as an example?
Yeah, actually, machine connectivity, well, let's take a step back. Why do we want to have machine connectivity? At the end of the day, we want to have the ability to draw insight from all the activities that are happening within the purview of additive manufacturing, whether it's managing your demand through production, through delivery. Because there's a lot of operational improvements or areas that we could hone in on to make sure that we can produce quality parts. So on the machine connectivity side, what we found is if you were to build this on your own, it is quite complex. It does provide high strategic value because especially on the production side, being able to capture, if you've been able to meet your fixed workflow, that everything during production was within tolerance level, that is valuable because now you can say, here you go, auditors, I have met all the needs. And you don't have to be able to drag all these logs together and demonstrate it. If that's all integrated in one place, it makes it easier. But the challenge, especially for machine connectivity, is that it's complex. There are machines that connect with OPC-UA, MT Connect, UMATI. These machine manufacturers also keep updating their software systems. It's a hard challenge to keep maintaining your operations to support all of this. So by working with organizations like ourselves, as an example, you can trust us to become the canonical data layer to translate, all this code into one vocabulary so that you can just work with that. And then we as operating systems could help develop the relationships with all the machines and make sure that everything stays up to date. And in partnership with them, making sure that when they release the next generation of their new, we're able to integrate that into your ecosystem so we can help reduce that off time as we help maintain this capability, as an example.
And we're talking right now about today. The challenges that we face today, but a lot of us got into additive for the future. The promise of additive and all the exciting things you can do with additive. So as you plan for the future, you need a foundation that works. What you have in front of you on this slide is what we call a maturity model. As you grow in maturity, you create additional efficiencies. Most manufacturers, additive manufacturers, acquired a few machines, started creating processes around those. Maybe it was a spreadsheet to track orders. Maybe they graduated to SharePoint, got rid of the whiteboard on the factory floor. They moved to a more informed, and a lot are now in a managed stage. They have processes, it works really well, but as they continue to evolve and want to get the benefits of automated and predictive decision-making, they're gonna hit a wall. What are the benefits, Janet, of the future in automated and predictive?
Yeah, so if we're able to take the lessons learned from the managed stage and digitize those processes, we can help provide more of an automated flow across all the processes, which if all the data is integrated across each operation, then we can start offering more advanced algorithms, applying more hierarchical algorithmic approaches to help forecast, to help identify where issues might occur in the production line, and then provide ways that could help folks solve problems while they're happening to avoid waste of resources, whether it's human capital or monetary resources.
Yeah, that's when you ultimately make your CFO happy, is when you get the automated predictive stages. And the way to break through this wall, as we call it, is really the need is a foundational architecture. On this slide, what you see is in blue, those are the applications or modules that you need. Order entry, production planning, all the way through post-production. It's the functions that a system like Link3D provides. In the white at the top, those are the API connections to other systems, like your CAD software, build preparation, slicer integration. And at the bottom, that's the translation of data from all of the IoT devices, whether it be machines to post-processing equipment. You need some sort of you need a foundational architecture to tie all this together for the future. Jenna, anything you'd add specific to aerospace here?
Yeah, I mean, at the end of the day, our goal here is to demonstrate quality and compliance, right? And to do that, we need to identify what is the